In this video, we're going to talk about chemical and physical changes and chemical and physical properties. So the properties of matter are the characteristics that that substance exhibits, giving it its unique identity. And they can be broadly divided into two categories: physical properties and chemical properties. A physical property is a characteristic of matter that is not associated with a change in its chemical composition. Some examples include density, color, melting point, and electrical conductivity. Chemical properties are those that are only observable when the substance changes into a different substance or interacts with another substance. So chemical properties are only observable when the substance changes its chemical composition. And some examples of these include flammability, toxicity, and acidity. Alright, so let's look at a couple examples. We want to classify each of these properties as being physical or chemical. So the first one is that mercury is a liquid at room temperature. Well, the phase of any material has to do with its melting points and its boiling points, and so that's an example of a physical property. Alright, the next one, the tendency of iron to rust. When iron rusts, it's reacting with oxygen from the atmosphere to turn into iron oxide, a new compound. So when we go from iron to rust, we're changing the chemical composition. So the tendency of iron to rust, in order to observe that, we have to observe the change from iron to iron oxide, and so that's going to be a chemical change. Alright, the density of lead. I can determine the mass of lead and its volume and then divide those two numbers. I don't have to change the lead into anything else to determine that, so that would be another example of a physical property. Alright, the fact that arsenic is toxic. The way I would know that arsenic is toxic is that I have to, give it to some living organism and then, see what the effects are, right? And in this case, the arsenic would undergo chemical reactions that would have an adverse effect on the living organism, and so that would be an example of a chemical property. Alright, and then the fact that sodium is a silver metal, the color is an example of a physical property. So closely related to chemical and physical properties are chemical and physical changes. Physical changes are changes that alter the state, the form, or the appearance of a substance, but they do not change the chemical composition. And so that's sort of the key difference, right? And so we're not making or breaking any chemical bonds when we do physical changes. Chemical changes are changes that do alter the chemical composition. So during a chemical change, the atoms that are present rearrange to form new molecules or compounds. Of course, as we'll talk about throughout the semester, all of the original atoms are still present, but we're changing how they're connected to one another. So we're changing the chemical composition in the case of chemical changes. Alright, so we've got some more examples here, and we're going to classify them as a chemical or a physical change. And so on our first one, a bowl of water evaporates on a hot day. So this just represents a phase change. And phase changes are always examples of physical changes. Whether we have liquid water or gas phase water, it's still H2O. It's still water, it's still the same compound. And so that would be an example of a physical change. Now, if I take an electrical current and pass it through water to form oxygen gas and hydrogen gas, I'm still going from a liquid to gases in this case, but now I'm converting the compound water into its constituent elements, oxygen and hydrogen, and so that would be an example of a chemical change. Alright, now if we put a log through a wood chipper, right, I still have the same wood, I just cut it up into smaller pieces. So I'm really just altering the form, but I haven't changed the composition. So that would be an example of a physical change. Now if I take that log and I burn it in a fireplace, that's an example of a combustion reaction. And when we burn things, we convert that substance into carbon dioxide and water, which is different chemical compounds than the ones that made up the wood, and so that would be an example of a chemical change. We've got the same log and we let it decay on the forest floor. So when fruit rots or when things decay, that's an example of chemical changes. If we have sugar dissolving in water, this is essentially just forming a mixture. And so that would be an example of a physical change. In general, when we have salt, when we have sugar, other compounds that are soluble, when those dissolve in water, we're just forming mixtures. We still have the same compounds present. And so that would be an example of a physical change. The bleaching of hair by hydrogen peroxide. That is an example of a chemical change. Part of the reason I included this one, while color itself is a physical property, when we have changes in color, that is very often indicating that we have a chemical change. It's not always, but I think more often than not, when you have color changes, that is an example of a chemical change. All right, and when we have an egg fried in a hot skillet, sometimes this one can be a little bit confusing. People say, well, we had an egg to begin with, we have an egg at the end, but almost all forms of cooking, especially that involve heat, those are almost always chemical changes. If you think about taking this to the extreme, if you left that egg in the frying pan for an hour, right, it would turn black and charred, essentially burned. And so, less cooking is just a less extreme example of that. When we cook an egg, we're denaturing the proteins. That's a chemical reaction. We have Maillard reactions going on. That's the browning reactions that give a lot of the flavor when we cook foods. So most types of cooking, especially those that involve heat, are examples of chemical changes. Okay, one last thing that I wanted to mention in this video that's sort of related in the sense that it has to do with properties. When we talk about properties, one category that we sometimes put them in is extensive and intensive properties. The difference between these two: an extensive property depends on the amount of matter present. And some examples include mass, volume, and heat. If we think about mass, it's pretty obvious, right? If you have twice the amount of a substance, its mass is going to be twice as big. So that's an example of an extensive property. Intensive properties do not depend on the amount of matter present. And some examples include density and temperature, right? And the way I remember intensive, these are independent of the amount of substance present, right? So intensive, IN, is independent of the amount of matter present, right? And if we think about density, if I have a block of gold, we know the density of gold. If I have twice as big a block of gold, the density does not change. And so density is independent of the amount of matter present, and so it's an intensive property.